to analyze data a little easier than I normally would, and I can look for trends. So what I have also done in order to assist you, there's about coincidentally also 13 people who have turned in the assignment already. And I went through there looking for the ones that were missed the most. There's a lot less problems than I thought too. I thought it was like in the 30s. It's only 21. If you actually count them up, it's only 21 problems. So I'm gonna do 4 of those for you. I'm just gonna give them to you. Happy Thursday. TBT, hash brown.
What's TBT?
And then whatever time is left over, then we can work on the assignment. So let's see who was listening yesterday. Have you ever, like in your life, had a noise other than that after hearing that there's a quiz tomorrow? Has there ever been like a yay or anything? No. Weird. Yes. It took my second period like 5 minutes to be able to give me this response. So let's see if you guys are a little bit more on point. What do you notice first here?
It's two terms.
Yeah, that's exactly right. Even though there's only one radical in the denominator, I don't care. As long as there's at least one radical in the denominator and there's 2 terms, okay? That means I have to rationalize first. And also the way that I rationalize is a little bit different than normal. What's that new word that we learned that we're going to memorize?
Conjugate.
Conjugate, good. What is the conjugate of 2 minus 2 square root of 3?
2 plus
square root
2
of 3.
Fantastic. Yes, you do, because in actuality, what are you really multiplying by?
The square.
Okay. By 1, yeah, we're really multiplying by 1. We're really multiplying by 1. And anything divided by itself is 1. Quick question, how many of you guys actually go back and like look at the videos that I put up there in class to go back and look at examples or anything? Is that something that we're actually even using? I'm just going through that trouble for nothing. I mean, I'll keep on doing it if anybody wants to, but like, everything that you hear and see now is there. It might be a different period, but same stuff. Okay, so now we need to go ahead and multiply. In the numerator, how are we going to multiply? What? One word.
Rational.
No. Distribute. Oh. Multiply -1 times each of those 2 terms. When you multiply by -1, all that happens is the sign changes. What did I? Oh, because I moved it. That's why. Let me just erase this. So I just distributed. Now here's the other $1 million question that goes in with the one we open with, because it's new. When you multiply conjugates, that's what I want to do in the denominator. What is the shortcut that we learned that makes our life easier? What is the result of multiplying conjugates?
The radical disappears.
How?
The fact that it's squared, and this is the square root.
3 words.
You have.
I think I even wrote it down for you guys yesterday. I don't know if I even wrote it.
Yeah,
3 words. Difference of squares, right?
Oh my goodness.
Very good. Good, Mimi. Difference of squares. It doesn't matter that my conjugates started off with like, oh, but you started with a negative and then you ended with a positive, or you started with a positive and you switched it. That doesn't matter. The fact is, anytime you multiply conjugates, the result is always going to be a difference of squares. What does the word difference mean? Subtract. So I'm always going to see subtraction. That's a very common mistake. I can guarantee you on the quiz tomorrow, I will see somebody put plus on the bottom. Minus. So difference, 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 difference. Put a minus. What does square mean? Difference of squares. What does square mean? No, use different words. You don't want to use the same word as definition. Willie Smith, what does square mean? By square number, what am I doing? Well, you could say multiplying by itself, but what's another way of saying it? Yes. Power up.
2 seconds.
Good. Second power. Cassie, do you agree? Cassie agrees. You writing all this down, Cassie? It's gonna help. Take off your tag and take out the notes. Get each of the terms and square them. 2 squared and then 2 square root of 3 squared. Which brings up yet another interesting point. I'm gonna hope that we know what 2 squared is. I'm not gonna even touch the top for now. Let's leave our focus in the denominator. We said we're starting with the second step.
What is that next to the 2? Is that a J?
Oh, it's an ugly looking parentheses. It's Julius's fault. J for Julius. So what's 2 squared? 2 squared is 4. I'm going to keep the minus because it's outside of the parentheses. But on the second square, you have to square both numbers. Squares are not distributable over addition, but they are distributable over multiplication. This means 2 times square root of 3. I have to square both of them. So again, 2 squared is 4. Yeah, this 2 is also going to be 4, but then square root of 3 squared is going to be a regular 3. The whole purpose of it was to remove the radical. So we were able to do that. No. So the next step, now we tried to rationalize. We wanted to get rid of the radical. We've accomplished that. Now we're looking to simplify. Simplify really means do any operation that's possible. More often than not, it's going to involve the radical. In this case, it does. Because why can't I simplify that radical?
Because it's a prime number.
Prime number. Wow, Julie's around 5 today, man. Good job. Why can't I subtract those 2 numbers?
Because they're not like terms.
Good. Yeah, they're not like. So the numerator is going to stay just like that. Dane, 4 times 3?
4 times 8 is 12.
Yes. So it's 4 minus 12. Is it clear? Clear, right? How's that pretzel? Fantastic. What's 4 minus 12?
I know.
Sarah, what's 4 minus 12?
8.
Not 8.
7.
No.
-8.
-8. Thank you. Whoa. What's this nonsense here? On this last step, things also get a little interesting. You're going to want to pay attention to this. I have now rationalized. I have now simplified. What operation have I not had I've not been able to do? Yeah, division. I haven't been able to divide. And in many cases, you will not be able to, and you will be done, and all the children will be happy because there's nothing else to do. But in this case, I can't fully divide, but I can reduce because all the numbers on the outside have a common factor. What can all those numbers be divided by?
2.
If you said 2, that's what brings up the interesting part. Here's why I find it interesting, okay? I have never known there to be a rule that says that you cannot leave a negative in a denominator. But I'm in the minority there. Like most places, when you're asked to simplify, would assume that you do not leave a negative in a denominator. In Khan Academy, if there were something similar to this and you left a negative down there, they would mark it wrong. You'll probably find teachers that will do the same thing. On what I mean for me is like if you did everything right and then on this last step you just reduced by 2 and the only issue you had was a negative, I'd still give you full credit. I wouldn't count it against you. But again, I'm in the minority there. Luckily, there's an easy fix for that. Instead of dividing by 2, what could we divide by to take care of the negative also?
-2.
Just -2, yeah, divide by -2. So if I divide every number by -2, that makes both -2's a 1, because -2 divided by -2 is +1, and it makes the -8 a +4. So now let's figure out what to write. In the numerator, we had 2 terms, and we still have to have 2 terms. The first term is a 1. The second term is now a +1 with a square root of 3. I need the positive. I don't need the 1. I do need the square root of 3, so that would be the numerator now.
Okay.
But what if I wrote the 1? Well, again, I tend to not like. You found it? Nice. That's not yours though.
I know, but I'm doing that.
Oh, that's true. If not, you know what happens. I don't think I've ever marked anybody wrong for leaving a 1 in front of a radical, but you still should. Doesn't mean you should be doing it. And on the bottom, you just get a 4. Any questions there? All right, and now these are going to be straight from the assignment. So that means instead of having a 21 question assignment, you really have a 17 question assignment. I'm going to do this for you. What operation are we doing here? We are multiplying on the outside, because with multiply, we got to check the indexes, but they're always going to be square roots for this quiz. So what's 2 times 1?
2.
2.
Oh, the answer C.
You're a C. But this is now where we might go different routes depending on how we feel about mental math. Because since we do not have a calculator, if you were to choose to multiply on the inside first, you would get 56q squared. Meaning on the next step, you'd have to do a tree with 56. If you feel comfortable with that, you're fine. But if you prefer to need the number small, the 14, yeah, you take a tree there. Can you guys see better with this program? Because this is the one I'm planning on using. 14 is 2 and 7. Do I have to do a tree with a 4?
Yes.
No, why not? Huh?
Because 2 times 2.
It's perfect. It's a perfect square. Okay, but fine. Here, I think I would confuse more people that way. So let's just go ahead and do it for Brian. Brian, that tree goes out to you. Keep living the tree. So whether you waited to do it with the 56 or you did it before, what prime numbers do we end up with?
3 2s and a 7.
3 2s and a 7. I don't care where you simplify, that's up to you. So this is the step that's kind of optional. If you feel it helps you, go for it. If not, I won't hold it against you. And that's to rewrite this and say, okay, 2, then here are your 3 2s, here's your 7, and then QQ. What can I bring out?
2 2s.
The 2 2s.
No, I can bring out 1 2. It's one circle that's around 2 2s. Why are there 2 2s? Because of the index. But it's one circle, Zakia. And then 1 Q. Is she okay? She's out for the count. Zakia, you alright? Hang in there. What's what? Those are Q's. What's a Q? It's the letter that comes after P. Is it P that comes after?
What is?
You don't think that looks like a Q?
That's a 9 with that.
A backwards P?
You write your P's with a dash through it with like a.
No, you did!
I write my 7 like that.
I've never seen a Q like that.
That's so cute.
No.
I thought it was a 9.
That was a 9.
That's the cutest cute ever.
Like that? Is that? I don't know how you write.
Okay. Oh my god. I know it's way too cute.
Oh.
Okay, so the 2 that was already on the outside times the 2 that's going to join it is 4. We also brought out a Q, even though you don't think it looks like a Q. And then on the inside, we're left with a 14. Even though this is not as interactive as like Khan Academy would be, it's not like you're getting the same types of feedback. At least I left it multiple choice. So there's a good chance that if you're getting the same thing that they're multiple choice, you can't be completely confident you got it right, but you can be somewhat confident. So which one's the answer here?
B.
B. B is for Brian. How did I get 14? The 2 and the 7 that are left. How did I get 4? The 2 that was already outside times the 2 that came out. All right, if you understand this one, you should understand everything that we're even though technically the answer choices are not in simplest form, but we're going to do it in simplest form. This is what I'm saying is that this is about as complicated as it'll get. So if you feel good about this one, you should feel good about all of them. On the quiz. You're an A. First step. Rationalize good, because we have to, because there's 2 terms. How are we going to rationalize?
We take that thing.
I think Tad knows. Does Tad know? Tad doesn't know? We've only done it once today, though. On the second time we get it. Deja, do you know?
No.
Bryce knows. 4 out of 5 Bryces agree. No? Lorna?
We'll be multiplying it by the denominator or 2 on 1.
There's a special word I'm looking for. Sam? You don't know the word?
No.
Nuha knows the word.
No, I don't.
Yeah, you do. Yeah, you do. Suna? Conjugate. Multiply by the conjugates. But watch. Now, yes, the part that you said about multiplying by 1, yes, you're correct. But you're not multiplying it by itself, and the bottom is multiplying by its conjugate. Yeah, you have to make sure that the 9 stays negative. Do not change the sign of the 9. The 9 stays negative, but now it'll be minus square root of 6. Coda? What do we do in the numerator? How? You don't know? Harris? Distribute, good. Negative 9 times 6 square root of 3 is going to be negative 54. Keep the square root of 3. It's just times tables. Going negative times positive is negative. 6 square root of 3 times negative square root of 6 is negative 6. And then 3 times 6 is 18. Last period, some jaws dropped after that stuff. Yeah, Sarah, yeah, it was that kind of look where you just gave me like, what? So let's go over it piece by piece. This first term came from that multiplication. This second term came from that multiplication. Other than that, it's just knowing your times tables. And then Brian, now you can really show off in the denominator what happens when you multiply conjugates. It goes in the bottom. Cody, I know you weren't here for this, but would you be able to answer that question? Mimi answered it. In the denominator, what happens when you multiply conjugates? Shut your... You bite your tongue.
We're gonna have to have the same.
What did you say, Ashley? Oh, now you forgot. Myra?
The difference.
Very good, Ashley. Difference of squares. Difference of squares. Hi.
Do you have Elizabeth?
Do I have Elizabeth? Yes. Are we still confused about that step? Difference of squares, just a shortcut. The only other way to do it is to FOIL. The FOILing takes you a lot longer. Difference means subtract, square means square both numbers in the bottom. Coda, you're still confused about that? There's two terms in the denominator, right? From the beginning we said -9 and square root of 6. Anytime you multiply a binomial by its conjugate, automatically the result ends up being a difference between subtraction of the squares of those numbers. It's just a shortcut. If you wanted to see the long cut, you would FOIL. If you FOIL, you would end up with the same thing, but we're just saving you time. That's what a difference means, yes. Subtract. Okay, so let's rewrite the numerator for just one more step, because my goal here was to rationalize, and I'm not done rationalizing yet, because I still see an ugly radical. Myra, -9 squared. Good. Keep the minus because it's outside of the parentheses. Cruz is your last name, right? I don't know why I keep on forgetting your first.
I know.
Isn't it? Is it David?
Yup.
Okay. Square root of 6 squared?
6.
Good. But I thought it was supposed to be like square root of 36. Okay, so now we've gotten rid of the radicals. What do the children do next? After we rationalize.
She said it.
What'd she say?
Simplify.
Simplify, yeah. Do any operation that can be done. Normally it's with radicals, but if there's anything else, adding, subtracting that can be done, you go ahead and do it. The radicals, why can't I simplify the 3?
Because it's a prime.
It's prime. The 18, though, I can. 18 is just going to be 2 3s and a 2. So I can bring out a 3. Because 9 times 9.
9 times 9.
Oh, wait, it was a -9 there, not a 9. So fooled you. -9 times -9. So -54 stays the same. Square root of 3 stays the same. I used to have a -6, but now it's going to get joined by a 3. So now I get -18. You multiply it. Square root of 2. On the bottom, we get a 75. So full disclosure, I got these problems from a worksheet, and it looks like the people in the worksheet that weren't thinking too properly, because if you look at all your well, actually, you know what? Maybe I shouldn't even show you this yet. Let's hold off on this. Let's go back here. But just remember this step right here. Because, all right, my question to you now is, we rationalized, we have simplified. You can't do anything else. The only thing else possible would be the subtraction, but you can't do the subtraction because the radicals are different. Okay? But we haven't divided. And maybe with numbers like this, it's pretty easy to ignore. I'm guessing whoever wrote this, probably that's the mistake that they made. If all of the outside numbers have a common factor, you're expected to reduce. What single number can all of those be divided by?
3.
5.
Zakia, do you know?
3.
I wonder if you know.
3.
3. It is 3. It's really boring. So we get negative if we divide by 3. You're setting a bad example. Bad. So wait. What's wrong with freshmen, huh? I divided all those numbers by 3. And that is correct. That is what should occur. If this problem were on a quiz, that's what you would be expected to do if you want full credit. But when you go looking for what we ended up with, we don't see it anywhere.
I told you.
So in this case, yeah, the next closest thing would be the step right before, which is this one here, but that's not because it's right. Whatever, that's as simplified as they got. I can't change it. I got it from a worksheet. Any questions? Claire, you got it? You ready for the quiz?
No.
All right. 2 more. Do you guys even like? It's all, look here. Watch. We'll do this because if you're gonna be falling asleep and talking and stuff, I got the laptops. I can give them to you now. You have about 20 minutes to work on them, or I can finish doing these from the assignment. I'll let you guys pick.
No, I'm gonna do laptops.
You right? All right, here, I'll let you. Let's do a show of hands. Laptops. Who wants laptops?
What?
All right. Who wants me to finish doing problems from the homework for you? All right. Well, there we go. So that one.
Maybe I'll fill in the quiz.
I'm really the teacher, so I'm gonna go and not Next.
All right. So let's go. What's gonna be the first step here?
Distribute.
Yeah. Square root of 6 times square root of 33. Megan, do you know what the square root of 6 times square root of 33 is? No. Does Chooks know? Does Chooks know? No. Remember that another option you have is just to do the trees when the numbers are smaller. It should be 198. 198. So if 198 is too big for you, you can do the trees when the numbers are smaller. And then you would know that, oh, that's ugly. You would end up with 1, 2, 2 3s, and an 11. You can do it that way if you want. And the next one's pretty simple because the 7's on the outside, so that's just 7 square root of 6. We already know that a tree for a 6 is 2 and 3. If you were to wait to do the 198 now, you would get the same thing we saw before, which is 1, 2, 2 3s, and an 11. So I could bring out a 3. What's going to stay on the inside?
2 and 11, so 22.
22. So I have a 3 square root of 22 plus a 7 square root of 6 because I can't do anything with a 6 because there's no pairs. There's no pairs of primes. I'm still being asked to add, but can I add those?
Nope.
Why not?
Because they do not
they're not like. So we come back and look up here. Do we see that anywhere? It is C and Julius. I think you would want to pay more attention to this than most. Because if you look over here at C and D, this step before we simplified was actually D. This was D. But here in simplest form was C. So yeah, technically they're both correct, but which one's more correct?
C.
Yeah. It's fully simplified. C. C is fully simplified.
You said the both of them. So you can pick either one.
No, you can't. If, the way that this thing is programmed, it would only mark C correct. I circled both of them because I wanted you to compare and contrast.
What was the answer for the last one?
A.
Is that all you're doing? You're just writing down the letter of the answer?
No, I'm writing down.
Shoot, I did.
It's A.
What would Julius do?
Nothing.
That's what you should ask yourself at all times. All right, last one. More of the fun ones. You can see why these are missed the most. These were the ones that were missed the most. So now for the fourth time in 2 days, what do you notice?
It's 2 terms.
Is this the exact same one I did yesterday?
Yes.
Does anybody have that written in the notes? Because if it is, then I'll just. That would be kind of weird if you guys did something. It's not the same. Oh, that's a big difference.
No, it was 10.
Yeah, this one has a 10 on top instead of a 3. All right, we'll see what difference it makes. Okay, so then just like yesterday, what's the first step?
Conjugate.
True. Rationalize the denominator. How? How? What? Nuha?
I don't know.
Correct.
Don't you like change the sound?
What's that called?
Conjugating.
Good, conjugate. Did you say conjugating? You turned it into a verb?
Yeah.
It's a noun. It's conjugate. Multiply by the conjugate.
That sounds weird.
So, Bri, the conjugate of square root of 7 minus square root of 2 is square root of 7 plus square root of 2. But even though I wrote a plus, when it comes time to rationalize the denominator, I'm going to write minus because it's the difference of squares. On the top, I distribute 3 square root of 7 plus 3 square root of 2. Big difference on yesterday's notes. There was a 10 up there. That's why in the notes we saw 10 square root of 7 and 10 square root of 2, but now we changed it to a 3. Changed everything. On the bottom, here is your minus. Square root of 7 squared, square root of 2 squared. Too fast? Oh, I just did a difference of squares. That you answered that before. Difference of squares.
I was writing something.
But those are the answers. We don't need to write those down yet. You just do the work, and then when you go home to enter them in, or wherever you enter them in, you just look for the one that we end up with. Can I simplify the numerator at all? No, because my radicals are prime, and I can't add because the radicals are different. So that's going to stay the same just like it did yesterday. So 3 square root of 7 plus 3 square root of 2. Over on the bottom, we just have a regular 7 minus a regular 2. So we end up with 3 square root of 7 plus 3 square root of 2 over 5. I have now rationalized. I have simplified. I have not divided, but can I divide? No, there's no common factors. Why did I get 7 where? Here, this 7?
What's
Seven.
7 times 7?
41. Wait, 7 times 7, bro.
49.
Oh, 49. That's what. So why isn't there like no 49?
No, because since it's a radical, it's a perfect square, so there's no 49.
Because it wouldn't be 49, it'd be square root of 49. So what's the square root of 49? Yeah. And see, the reason why you don't need a calculator is because as long as the attention has been there, I know it's hard. Every year we have shorter and shorter attention spans. I know it's hard. But I taught you a trick. So that there's no math involved. If ever you have a square root that is being squared, I even did like theatrics and everything, because then I help it sink in. They cancel each other out. What do you end up with? Just a number on the inside. You don't remember the sound effects? Claire remembers. And annoying. All right. So sorry for the tease, but it looks like if I were to give out the tablets now, by the time you sit down, I'll be picking them up again. So what I'll just do is, I'm sure you'll object to this, but I'm gonna go to the assignment. I'll just keep on doing 1 through 5 on the assignment until we run out of time.
Wait. Is this A, B, C, or D?
That's the important part, right? Is this A, B, C, or D? Must know the answer. Oh, that's actually it's actually a better question than I thought. Because I don't see the answer here anywhere, Mr. Romero. They did not write this exactly as it was anywhere, but there is a variation of that. For whatever reason, they just chose not to distribute the 3. So let's focus first on the denominator, because that has to be rational, right? Which ones have just a 5 on the bottom? A and C. So I know for sure it can't be these 2. What's the difference between
Positive and negative.
the plus? Yeah, so it's gotta be C. But don't do that on a quiz. Leave it with the parentheses. Parentheses, get rid of them. Here, I'll do some more then from the assignment. Does anybody have any requests? Did anybody get started with the assignment and there's something that's troubling them? All right, so then I'll pick one. This one seems good. Choo. How about this one? This is a nice example of how you can start 2 different places and end up with the same answer. This is actually a very good example for this. We're dividing. What? I don't know if I want to say should. I don't want to say where should you start, but where at least do I like to start if possible? The dividing, right? But 99 cannot be divided by 45. Inside with inside, outside with outside. Those can't be divided, but they can be reduced. So here's what I want to kind of propose to you. I show you that this shows off kind of some of the benefits, right? Let's say that you said, oh, but look, you know what? I'm starting to get a feel for this whole rationalizing thing. Let me just rationalize now. Yeah, on the bottom, you're just going to get a 45. On the top, it looks like you're going to get 405. I think that's 405. If you can even do that in your head. Actually, no, that can't be 405. It might be 4050.
It's 495.
100, wait, 4500. No, it will be 4440. See, even I can't do it in my head. 4465. So who has a calculator? Check 99 times 45. I think it's 4465.
Wait, you said no calculator.
I understand, but I'm perfect. I'm showing you why. I'm not going to do it this way. Like, I'm not going to do it this way, but that's what I'm going to show you.
Ow.
Even I have trouble doing it in my head. I think it's 4465. It is 4465, so it's 55. Okay, so there you go. I was off by 10. So that just goes to show you that if we prefer, if we can divide, let's do so. And even though we can't divide, we can reduce. What's the biggest number I can divide 45 and 99 by?
9.
By 9. Good. So that's what I'm going to start off doing. I'll still write the 4. This becomes an 11. This becomes a 5. I divided each number on the inside by 9. So that now, when I go to rationalize that's what comes next. My life's a little bit easier. Ashlyn, what am I going to get in the numerator?
4 and then 55.
4 square root of 55, excellent. And in the denominator?
5.
That's 5. I have rationalized, I have divided. I have not simplified. And 55 is just a 5 and an 11. So I can't do anything with that. Also be aware when you start off dividing, there's a chance you might have to divide again at the end. But in this case, 4 and 5 are not divisible. So I'm actually done. Then Julius, the more important part, which answer is it?
B. Oh yeah.
I can do one more. Any questions on that one? Let's make it a good one. Mm-hmm. Brian, stop being so popular. Whoa, 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 whoa. What operations are we doing here?
Adding and.
Yeah, we're adding and subtracting, which is just kind of like combining. In order to combine, the radicals have to be the same. The radicals do not need to be in simplest form, but if they're not the same, you could simplify, yes.
What's going to be multiple
We should find out tomorrow.
Why can't you
Doesn't matter, I gotta show work anyway, so. I wanna know. Just tell me now. Can any of those radicals be simplified?
Yes.
No. 19 is prime, and 6, even though you can try, with the 6 you can try. It's neither prime nor perfect, but it's just a 2 and a 3. So let's just look then for if we have any like, because if not, it's going to stay like that. Well, we do have some that are like. It doesn't really matter the order, but let's do the 19H's first. I have a positive 3 and a negative 2. 3 minus 2 is? 1, but I'm not going to write the 1. I'm just going to write square root of 19H. Those are done. Now let's do the 6 G's. What is positive 2 plus 10?
12.
Plus 12, square root of 6G. Which answers that? It's B. Yeah.
It looks complicated, but it's not.
Is that a 6? Is that what you're saying?
She said that's
In this case, yes. Because I can't do any more radicals. I can't do the addition. I will leave it there.